Welcome to my channel Chemistry Class. Welcome back to Chemistry Class, my dear student. I hope you are doing well. So, in the last lecture, we discussed the law of mass action and learn how the mathematical form of law of mass action is expressed. And today, we will discuss another very important concept, which is condition for equilibrium. My dear student, this help us to understand when a reaction actually reaches a state of equilibrium. So let's understand step by step. Now, introduction. My dear student, chemical equilibrium is not established immediately. It occurs when the rates of the forward and reverse reactions become equal. This means that the amount of reactants and products remain constant with time, although both reactions are still occurring continuously. Now, condition for equilibrium. Dear student, for a chemical reaction to attain equilibrium, three main conditions must be fulfilled. The first one is the reaction must be reversible. And the second one, the reaction should occur in a closed system. And the third one is rates of forward and reverse reactions become equal. So, the first condition, the reaction must be reversible. When a student, only reversible reactions can reach equilibrium. Example, N2 gas plus 3H2 gas GAF 2NH3 is also a gas. When a student, if a reaction is irreversible, mean goes only in one direction, equilibrium cannot be established because the backward reaction does not occur. And the second one is the reaction should occur in a closed system. But dear student, the system must be closed so that neither reactants nor products can escape. This ensures that molecules of both reactants and products remain present and can react freely in both directions. Example, formation of ammonia in a closed container allows both forward and reverse reactions. If the container is open, ammonia gas will escape and equilibrium cannot be achieved. Now, the third condition is rates of forward and reverse reactions become equal. When a student at equilibrium, rate of forward is equal to rate of backward reaction. At this stage, the concentration of reactants and products remain constant. Example, H2 gas plus I2 gas give 2HI is also a gas. When a student, initially the forward reaction dominates and HI forms rapidly. As HI builds up, it starts decomposing back to H2 and I2, meaning reverse reaction. After some time, both reactions proceed at the same rate, meaning equilibrium is achieved. Now, important points to remember. For dear student, these are the important point which is you remember. At equilibrium, the rate of both reaction is equal. The concentration of reactant and product become constant. The system must be closed and reversible. Equilibrium is a dynamic state, not static. So, my dear student, this is all about today's lecture on conditions for equilibrium. I hope you understand. So, if this lecture will help you, then don't forget to like the video, subscribe to the channel for more chemistry lecture, and share it with your friends. Comment us your question below. Take care and see you in the next class, inshallah. Thank you for listening.